So let's actually see how to run some code on a fly machine. We have some code here. This code assumes a user package, some user code is in the package directory and at index.mjs. This will just run whatever function or closure that package provides, right? So what we need to do is one, create a Docker image that packages up our code here. Two, create a fly machine to run that code. And of course, part of that number two is to actually have some user code available for this to run. Very quickly, let me just show you the example user code I have here. I have a package directory. In that package directory is an index.mjs file. Inside that index.mjs file is some user code. That user code just calls the AWS S3 client. And I'm really just doing a call that's going to fail. It just doesn't matter because it's some user code here. It's an example, right? This code is going to call the S3 clients, get object command method or function or whatever, with a fake bucket and a fake key that I think actually exists in reality, but it's just gonna fail. We won't have permission to talk to this bucket. It doesn't matter. I just want to show you running some user code, and I want to show you running some user code that has a node modules directory, right? Because it has some dependencies. Okay, so the only other notable part of this is that it's exporting default and asynchronous function, right? So that's what our code here is going to expect. It's going to call that handler method, the thing we name handler, that async function we pass back, and it's just going to get the result from it. Perfect. Okay, we have some user code. We need to create an image that will run this code and then call the API to spin up an image, spin up a machine, right? A fly machine, so that it runs our code, and our code, it of course needs access to that package directory, the user code. So first things first, let's go ahead and do a Docker build here. That is going to build our current code from our current directory here. It's going to be part of our random application, and we're going to tag it user code because it's just the image we're pushing up that actually happens to run user code. Now, just before I run this Docker build, I want to show you one thing in our project here, and that is I have a Docker ignore file that is going to ignore the package directory and a package.zip file and an old user code MJS file from my testing previously, just in case you were wondering if I was accidentally about to push user code up as part of this Docker image. I am not. The user code is not going to live in this Docker image by default. So I'm not trying to tell you to create a Docker image for every single customer of all their code that they might upload to your service, this fictional service we're talking about. Okay, so back to our command here. It's doing Docker build to our registry, and it's going to build from the current directory. That's perfect. This should be nice and quick because I've already done this in the background or previously when testing, and it is. And once that is built, we can do a Docker push. So we're going to push up to the registry.fly.io at the random application. The user code tag is just what we're using. It's just what we built. We're going to reuse that tag here. That's the image name and tag that we are going to use to run user code. So that'll be pushed up to the fly registry, and then we can spin up a fly machine that uses this Docker image to run. But of course, I keep saying it, but I haven't shown you yet. We need to get the user code in place so our machine actually has it to run. So how are we going to do that? Well, I have already shown you the mechanism of how that happened in the previous video when we checked out the Docker file and the entry point script and all that stuff. So all we really need to do here is to get that package directory in the right place, or the package.zip file rather, into the correct place when we spin up a fly machine. So we're going to call a curl request here. We're going to make another curl request to the machine's API to spin up a machine, and it's going to use the payload of this machine.json file for the contents of it. And that is the important part here. This is actually going to use a feature of the fly machine's API to create an image on the fly within the fly machine. I keep using the word fly way too much. I hope that's totally clear, but if it's not, you can always ask questions in the comments or on the Fly's community forum at community.fly.io. Okay, let's go ahead and see this machine.json file so we can see what I'm talking about. Actually, you know what? No, let's go ahead and see documentation. Yay. So this is the documentation on creating a fly machine. I'm underneath the config. It's all the way up here. I'm underneath the config heading, the config object, whatever. A sub object of the config object in the JSON that we are creating in order to make a payload for the machine's API is this files array, an optional array of objects defining files to be written within a machine. So you can actually create a file on the fly within a fly machine when you spin up a fly machine, when you start or create a machine. They can be either a raw value, which is a base 64 encoded string, or the name of a secret that you have previously set. So you can have a file and the contents of that file will just be a secret, which is pretty neat, but we're not using that feature. We are going to base64 encode a zip file and include that here. Now, the Fly Machines API has limits on the size of the payload you can send it, so you cannot send a large file. This is why I have elected to not package up my node modules directory from the user code example I have, right? That packages directory with the packages.zip file we got to create doesn't have the node modules directory in it. That is why, I think I mentioned that in the previous video, that's why the entry point script that's going to run the user code runs the npm CI call in order to get the dependencies for us. It's just how I chose to run this example. You might want to do that differently in your case. You might not be able to use the Fly Machines API to create files because of the file size limit, or you can find tricky ways around that. I'm hoping to make other videos to show you other examples of doing that so you don't run into issues making an API call trying to make a large file, because it's kind of a clunky process. But it's really nice if your file sizes are small, or if you make like a workaround where the file you're creating just has metadata and that tells the code that you have here how to find the actual files. There's all sorts of possibilities on how to get around that. But let's actually see that. First, I need to package up. I totally forgot. I need to package up the user code. So that's going to be a zip call. I'm going to package up the zip directory. I'm going to create a file named packages.zip, and we're going to exclude the node modules directory. So we can see it just packaged up the few files that are actually in there that are not in the modules directory. And so my zip file is very small. Great. So I can base64 the package.zip file and put that into my clipboard. I'm on a Mac here, so pb copy works. That just puts the contents in my clipboard. And when that's done, I can create this payload, the machines.json file payload. So the image that it's going to use is the one we just pushed up to the registry, the user code image. 2 CPUs, 2 gigabytes of memory again. It's all the exact same stuff, auto destroy when you're done. The new thing on this payload is the files array, and it has a guest path of user source app package.zip. Now the user source app directory is, if you might recall, defined in the Docker file as the working directory for the code that is running in the machine that we've created, or the Docker image we created, which is going to spin up a Fly machine. So that's the working directory. This is where the package.zip file is expected when we run our code. And if I just scroll down here, we're in Vim, so it looks up a little funky, but the raw value is going to be the base64 encoded string of the package.zip file that I just showed creating. All right, so this machine.json payload file is all set. We can make our curl request now, and it's just going to spin up a new machine, right? A post request to the /machines endpoint for our random application using that machine's JSON file we just saw for the payload of it. So let's go ahead and spin that up. And then I'm going to do fly logs on our random application. I'm going to use this terrible looking awk function or call or whatever to print out just a few columns. I think everything after the 4th column or whatever of the log output. So it's a little more readable, just so we don't have all this junk filling up my lines. Since I have a large font here for readability, that ironically makes it hard to read. Great. Okay, so we're writing the file. So this is spinning up a Fly machine. It's writing the file package.zip based on that API call. It's choning the file as it needs to, and then it's running the entry point to our machine. And that entry point is going to find the package.zip file, right? Found it. It's unzipping it. You're running the unzip function or call or whatever. And then, so that inflates, right? Deflates, inflates. It's inflating, I guess, our package.zip file to make the files bigger, right? Okay, and then it's running the npm CI call. So it gets our npm dependencies, and then it's going to run our user code. Now, of course, we expect an error here because I didn't set a region, among other issues, with that call to the AWS S3 API. I didn't set a region. Even if I did, I wouldn't have permission. I don't have any AWS keys or secret keys set here. The bucket I named is a bucket that exists in, let's see if we can find it. It exists in some region I've never used before anyway, like US EU1 or something. It's probably a real bucket. Someone created a bucket called some bucket at some point in AWS S3's history, right? So it exists, but we don't have permission to talk to it. So that fails, but this actually did run our user code, and then it exited, and then it destroyed that machine. So that machine is not up and running still. We're not paying for those compute hours. So we've done it, right? We've run some user code using this method. We made some code that runs user code. We created some user code. We created a machine that we can reuse, right? We can keep reusing that Fly image, and that can just run user code for us and report the results back in our logs here and all that good stuff. The trick, of course, is getting the user code into your machine. I showed you one method, which is to use the fly API method of creating a file on the fly. But there are, of course, all sorts of mechanisms you can do to create files or get user code onto your machines as well. In future videos, I'm hope to talk to that to show more examples, but for now, I'm going to leave you with this, which is, I think, kind of the neatest way to do that. And of course, I wanted to show you that feature of the Fly Machines API. Okay, so that is running user code. If you have questions, if you want to see more examples, if you want to talk to the Fly team about how you might run compute on Fly, especially in a dynamic way using Fly Machines, you can ask questions in the community forums, right? community.flyio.com. That's not right at all. community.fly.io. Or you can email support, or you can comment in the YouTube comments down below.